We only have to play 3 rounds of this game to understand entropy completely. Now you probably completely lost track of where the marble is. You just went from this probability distribution in your head, you knew exactly where the marble was, to this probability distribution. That's what a positive change in entropy looks like. Now, in the second round, I will go a bit slower. You probably were able to track the marble. You just went from this probability distribution to that probability distribution. That's what zero change in entropy looks like. The probability distribution is just as narrow as it was before. And now in the last round, I will not show you in which cup the marble is. And now, after shuffling, and after not knowing in which cup the marble was to begin with, if you now confidently knew in which cup the marble is, that would be a negative change in entropy and the point where you broke the second law of thermodynamics. There's an important nuance here though, that has been lingering in my thoughts for a while and I was only recently able to fully integrate it into my worldview. Entropy is not a property of the fundamental reality, whatever that is. It is instead a measure of our lack of precision to specify reality's actual state. If I go so fast that you can't keep track of the marble, in reality nothing changes. The marble is still always just on the one cup. It's just you who lost track of it. The difference is in your head, in your perception of reality. Similarly, if I perceive something as going from a crystalline phase to a liquid phase, microscopically, the entropy is not actually changing. Entropy is not a property of this microscopic world. Each atom always has a position and a velocity, just like the marble is always just on the one cup. Nothing changes about that. The precision of my description of reality, that is what's changing. If I describe something as crystalline, that's a pretty narrow description. It implies very specific distances between the atoms and so on. Only very few of the possible atomic arrangements are in line with that description. Liquid, on the other hand, essentially translates to, now I've completely lost track of where the atoms are, but they must be in that blob somewhere. That's way broader. Entropy measures how broad, how unspecific our descriptions are.